To solve a system that has more than two variables by elimination, we want to eliminate variables one by one. So in this system, we're going to perform some row operations. So we'll name each of the rows row 1, row 2, and row 3. Now a row operation means that we do something to a row. We multiply it by something. We divide each term by something. So if you look at rows 1 and 2, it would be fairly easy to eliminate z from those two equations because we already have positive 4z and negative 4z. So the first row operation we're going to do is just row 1 plus row 2. So I'm going to rewrite both of them. 2x minus 3y plus 4z equals 2. And 4x plus 5y minus 4z equals 16. And we're going to perform the operation row 1 plus row 2. 2x plus 4x is 6x. Negative 3y plus 5y is 2y. 4z minus 4z cancels. 2 plus 16 is 18. Now we're going to keep that equation and save it for later. So now we've eliminated z from row 1 and row 2. And now we want to do something with row 3 and also eliminate z from another pair of equations. And this time let's use row 2 and row 3. So we definitely have to use row 3 because we haven't used it yet. We could eliminate z with row 3 and row 2 or row 3 and row 1. So if we look at row 3 and row 2, we have 12z and negative 4z. So the way that we would eliminate z's there would be to get negative 12z and positive 12z. We already have the positive 12z in row 3. To get negative 12z in row 2, we would multiply that whole row by 3. So now we're going to do the row operation 3, row 2, plus row 3. So we're going to multiply row 2 by 3 to get 12x plus 15y minus 12z equals 48. And then row 3, we're just adding to it and we're keeping exactly the same. X minus y plus 12z equals negative 9. And we're going to add those two together. 12x plus x is 13x. 15y plus negative y is 14y. And 48 minus 9 is 39. So now we've used the equations to eliminate z and to eliminate z from the first two equations added and from equations 2 and 3. And if you look, we have now two equations with just x and y, so we have a normal system of equations. So our new part of this system is just 6x plus 2y equals 18, and 13x plus 14y equals 39. And now we want to, from this new system, or from this new part of the system, we want to try to eliminate either x or y. And looking at how the variables are lining up, it would be easier to eliminate y because 6 and 13 for the x's are not multiples of each other. So in order to eliminate y, we would want 14 and negative 14. So we want to multiply this top equation by negative 7. Doing that, we get negative 42x minus 14y equals negative 126, and then we rewrite the next equation, 13x plus 14y equals 39. And then we're going to add these two equations together. Negative 42 plus 13 is negative 29x. The y's cancel, and negative 126 plus 39 is negative 87. And now we want to solve for x, so we're just going to divide by negative 29. And we'll get that x is equal to 3. So once we have that first solution, we're going to substitute back in order to get the other 3 variables. And first, we're going to substitute back into one of our 2 variable equations, so one with just x and y. We're plugging in 3 for x. So that would be 6 times 3 plus 2 times y equals 18, which would be 18 plus 2y equals 18. We solve for y. So subtract 18 from both sides and get 2y equals 0. Divide by 2, and we get that y is equal to 0. So now we have x and y, and we're going to substitute back into one of the original 3 variable equations to get z. So let's substitute into the first one, row 1. So row 1 was 2x minus 3y plus 4z equals 2. And we're plugging in y equals 0 and x equals 3. So that would be 2 times 3 minus 3 times 0 plus 4z equals 2, which is 6, and 3 times 0 is 0, so plus 0 plus 4z equals 2. So 6 plus 4z equals 2. Subtract 6 from both sides to get 4z equals negative 4. Divide by 4 to get z is equal to negative 1. So our solution is x equals 3, y equals 0, z equals negative 1, or written as a coordinate point, the solution is x comma y comma z, so 3 comma 0 comma negative 1.